our speaker for today.
Thank you. Okay, I'll make sure I'm on my mark. Okay. Hi, there he is. Okay, well, I'm very happy tonight to welcome Dr. Michael Erb, and he is a climate researcher and birder. He's right now in northern Arizona, but in a couple of weeks, he's going to be moving back to his home state, to North Carolina, with a different role. He was born in North Carolina. He attended college at University of North Carolina at Asheville, and that's where he's going back. That's kind of like a magnet, going back home. He researches weather and climate at Northern Arizona University. And here's what really endeared him to me. Outside of work, he is an avid birder. He's fascinated by tiny warblers and big water birds alike. So how can you not like somebody like that? I mean, likes them all. And he is going to talk to us tonight about something he knows a lot about: adaptations that birds have to deal with weather, and of course, we know now, climate. Because birds live everywhere, from the cold of the Arctic, the cold of the Antarctic, all the way to the desert. You know, there is no place you can't go to not find a bird. You're just going to find them. They're going to be there. And they are living there with these adaptations so that they don't croak, right? So we're going to find out a lot more about that tonight. We're going to hold the questions, if you will, until the end, and we'll have time for Q&A. If you have any questions, just tuck them away in your brain. And those of you who are on your online, we'll get to you in the chat and open it up to questions there too. So, Dr. Erb, it's all yours. You want to share your screen?
Great. Thank you for that introduction. Can you hear me all right?
Let's see.
Yeah, so like you just heard, I'm joining you from northern Arizona. It's quite nice here. I'm sorry to hear that it's fairly hot down in Texas. I did actually live in Austin for about 2 years, so just up the road from you guys, after leaving, getting my PhD in New Jersey. So I'm going to go ahead and share my screen. And can you all see that all right? Okay, I can't hear anything, so I'm assuming that is fine. So yeah, tonight I'm going to be telling you about birds and the weather. These are two favorite subjects of mine. I do a lot of research about weather and climate through work, and I love birding just for fun. So here's me. My new job, which I've already started, I'm going to be a research associate professor at Appalachian State University, researching weather and climate. I'm also author of several weather mysteries, kind of fictional weather-themed mysteries, and bird coloring books, which I'll probably mention at the end. And I'm an avid birder. And one thing I thought was fun, in the announcements, you guys just heard about a Purple Martin event. When I lived in Austin, I went to a Purple Martin flock. And you can see here's two photos. I was in a parking lot. I don't know if it was a HEB or something else, but you can see all these Purple Martins swirling overhead. And then as the sun set, they came to roost in a nearby tree, or probably several nearby trees. And it was actually quite a spectacular event. So I hope you guys can experience that too. Before jumping into the main topic, birds and the weather, I thought I'd introduce you guys to Arizona a little bit. Since we're joining remotely through the power of the internet, we'll take this as an opportunity to do just a few minutes of virtual birding. This is one of my favorite spots. This is just south of Flagstaff, called Kachina Wetlands. You can see in the distance here, this is Mount Humphreys, our highest peak. And a little bit in the distance, there's some water, which the birds love. And so if we go a little closer to that, we can see some birds. These are all birds that I've seen and photographed, but I just wanted to give you a taste of some of the birds that we have here. And some of these might look familiar and some of them might not. Now, here's a ruddy duck. This is a male. He's trying to impress a female, so he's flying low over the water and flapping his wings along the water and splashing. And then he comes to a standstill on the water and he lifts his tail up. In this case, he was unsuccessful. The female seemed uninterested and went away. Here's one of my favorites, a red-winged blackbird. Again, this one's trying to get some attention, it's sitting on a cattail. It's showing those bright red epaulets on its shoulders and trying to impress some of its neighbors. A yellow-headed blackbird. This one's nice just because it's so easy to remember what it's called, but it has those vibrant yellow and black. I like great blue herons because they do kind of remind me of dinosaurs. They're these large creatures. They have these long toes and long bills and um, quite notable, easy to spot. Canada goose and gosling. Um, just over one of these water ponds, here was an osprey that was fishing. They're fun to watch. They'll circle overhead, and often when they spot something, they'll slow down and they'll kind of hover in the air and they'll slowly fall. And then if they still see the fish, they'll fall more quickly. And this one has grabbed a goldfish. Looks like quite a big goldfish. Here's a common yellowthroat, bald eagle with quite impressive claws, lesser goldfinch. And one of my favorites, here's a yellow warbler. I love yellow birds. So anyway, since we're joining from such great distances, I thought I'd give you a little taste of birding in northern Arizona. And now on to our main topic. So birds and the weather. As I said, these are two of my favorite topics, and the intersections here are really interesting. So let's start by talking just about the weather. Weather around the world can be extreme. So let's take a tour of just some example places. Antarctica, months of continuous darkness. Temperatures well below freezing in winter, extreme winds, a very windy continent. The Sahara Desert, very different, limited water, extreme heat, few resources like food. Tropical rainforests, again, very different. Lots of water, lots of heat, vegetation, and other life. The Southern Ocean, this is the water surrounding Antarctica. We have stormy seas and massive waves. And even in the US, we have quite a variety of weather. Death Valley, it's the hottest temperature officially recorded of 134 degrees Fahrenheit and has limited water there. The Gulf Coast, you guys are more familiar with. Pretty intense heat, and sometimes, especially on the coast, you have devastating hurricanes. And Alaska, long snowy winters. And yet, in all of these places, you can find birds. These are places that would be very difficult to live for a human being without significant resources, but birds seem to be able to live there and even thrive in these wonderfully different places. They've diversified to live on every continent on the earth. Like I said, they thrive in the hot, cold, dry, and wet places. So during this talk, we're going to take a look at how do birds deal with this sort of diverse and wild weather. And let's start, maybe a nice topic for you guys to think about. Let's start with cold weather. You can take your minds away from the 100-degree heat down in San Antonio right now and think about the cold. So, and one very cold place is Antarctica. Penguins have colonies on the coasts of Antarctica where winter temperatures can drop below negative 50 degrees Fahrenheit. Not only that, penguins stand on the ice. They can't put on any shoes, so they have to have their feet directly in contact with the ice. And so that, in combination with the intense cold, the intense winds, seems like it makes a very harsh living condition. But winters can be cold lots of places. Even where I am, Flagstaff, Arizona, we can drop below 0 degrees Fahrenheit in winter. Birds can't go inside, grab a blanket, and sit by the fire. So what do? So here's our question for this section. If you're a bird, how do you stay warm in cold places? Well, probably the first thing that comes to mind is feathers. Feathers are great insulators. Birds, like this dark-eyed junco here, they can puff themselves up to trap warm air and give them a bit of buffer between themselves and the cold. Some birds grow more feathers in winter, so they have even more of that insulation seasonally. And this is why blankets and coats are often filled with feathers or down because they are such a great insulator. They do such a good job of separating a bird or a person from the elements. Another great feature, this is a social thing, is to find company. So in Antarctica, emperor penguins will huddle together in the winter, especially just to have less of their skin, less of their feathers being in contact with that very cold air. They're reducing their surface area as a group and using that communal body heat to keep warm. But not just penguins, other birds do that too. Here are some tree swallows in the snow, and as you can see, they're all bundled together for a bit of warmth. And for all of these photos, if I didn't take the photo myself, I do credit the person, so you can see here that this one was taken by Keith Williams. Another strategy is, if like these Canada geese, you have a lot of neck and you have a lot of legs and you have a lot of surface area, you can tuck your neck and your feet away. You can place them next to your body like you see these fellows are doing here, again, to reduce the amount of surface area. By reducing the amount of surface area, you're limiting your contact with that cold air and you're able to stay warmer. But what about ice? How do birds stand on it? If you've ever tried to stand on a cold surface or even ice, you know that it's hard to do. It's very cold. In very short order, a person would start to get frostbite or some other damage to their skin, but birds seem to be able to do it without problem. And many birds, to do this, they have a neat feature called countercurrent heat exchange. And you can see it here in this diagram from All About Birds, where blood goes to the feet and blood leaves the feet, but actually the blood going to the feet and coming away from the feet is very close to each other. Um, so the artery and the vein, the blood coming and the blood going are right next to each other. Those veins are. So heat actually gets transferred from the blood that's going down to the blood that's going up before it gets down to the heat, down to the feet. So in essence, instead of allowing that heat to get down to the surface where it would be lost to the ice, it's taking a shortcut and then heading back into the core of the body. So in essence, they allow their feet to become very cold so that they're not losing their body warmth by standing on that ice. Bird feet also don't have much muscle. Compared to us, well, we have fat and we have muscle. That stuff gets cold, it gets damaged. Bird feet don't have as much of that, so that helps prevent frostbite. So that's a great feature in helping them be able to stand on ice. If you've ever seen Canada geese stand on a frozen lake or something like that. Okay, so let's shift over to talking about the nighttime. Even when it's not winter, nights can become pretty chilly. Some birds have a strategy for this. It's called torpor. I think this is really neat because essentially it's like a hibernation. Whereas a bear might hibernate for a season, hummingbirds hibernate just for the nighttime. So they allow their body temperature to reduce during the night. So instead of spending resources trying to keep their body warm during the night, they just allow it to get cold. And then when the morning comes and when it starts warming up and starts becoming lighter, they start warming themselves up. Now, this isn't perfect. Since they do become very cold during the night, it means that they're not very uh, active. They're not very agile. So if a predator were to find them sitting on a branch in this torpor state, they wouldn't have much defense because it actually takes them a couple minutes to uh, come back to full activity. And hummingbirds do this in particular because they're so small. A hummingbird burns a lot of calories. Their metabolism is so high that if they didn't do this and they tried to use their metabolism to stay warm during the night, they might starve to death overnight. Just in trying to sleep and trying to keep up their warmth, that metabolism would burn through their energy resources and they might not make it to the morning. So they have this state called torpor, where they allow themselves to have this mini hibernation. And there's some other birds that do this, chickadees and kinglets. And this is an image from a paper of a bird, a blue-throated mountain gem. This is the same bird at several points during the night. And you can see this infrared image. It starts out relatively warm, and then as the night progresses, the bird allows itself to become cooler. And then when morning comes, it will uh, make itself warmer again. Birds can also shiver. So, like people, birds can shiver. And this is just a little mechanism where you're kind of trading your energy for movement. So something that you eat, those calories, you're burning a little bit to produce that shivering motion, and that also produces heat. However, since this uses energy, and a lot of times birds are right on the edge of having enough energy to do the things that they want to do, it's not the best solution for keeping warm, but it's something that they can do. Another feature, and we're nearing the end of this cold section, we have Bergman's rule, which says that in general, bigger animals can maintain their body temperature in the cold. So if you imagine penguins down in Antarctica, where it's incredibly cold, you have larger penguins, like emperor penguins. And then as you go more to the equator, where it's warmer, you tend to have smaller penguins. Because in those cold places like Antarctica, being big can be an advantage. You have relatively less surface area compared to your volume. So it's a little bit easier to keep your core, warm. And of course, there are big birds in warm places. This is not a ironclad rule, but it is something of an observation. Also, if you have a flock of birds, it seems like larger birds are better able to survive cold snaps. So if you have a couple days in the winter where it gets incredibly cold, it seems like the larger birds have a better chance of surviving in a given flock. Other things that birds can do. Well, one, they can eat lots of food. If a cold snap is on the way and a bird has eaten well, it has a lot of energy and fat that can help it survive that cold. Other birds will find a warm place to stay. And for example, the ruffed grouse can even make dens in the snow, make a igloo of sorts, uh, to have a little bit of shelter against the elements. And of course, if it gets too cold for you in one place, you can do what a lot of birds do and just migrate somewhere warmer. And keep this in mind. If you have any questions, we can chat about those at the end. But I would like to move on to a topic that's maybe more in your mind right now, hot climates. So there are a lot of birds that live in hot places. For me, southern Arizona, that would be the Sonoran Desert. And you can see here two curved-billed thrashers down in Phoenix that are building a nest of twigs in a saguaro cactus. And hot climates present other challenges. Well, one, if it's hot, you want to be able to stay cool. But also, if it's hot, you might have a harder time finding water or retaining water. So, how do birds handle these two problems? And let's check out the first one first. How do you stay cool in hot places? Well, one thing you can do is find shade and chill out. Um, a lot of birds in hot places, they become less active in the hottest parts of the day. You can see this is also Phoenix. This was a Cooper's hawk hanging out in the shade. You do see it with its mouth open. It is panting a little bit, which we'll talk about later on. And going along with not being as active in the warm parts, some of these adaptations are keeping the same mate year round. So uh, if you already have your mate, you don't have to spend a lot of energy, perhaps in the heat, trying to impress someone, or fighting off rivals. And in general, just not fighting broadly, because fighting for territory or for mates, if it's really hot outside, that's going to cause a problem. So a lot of these birds in the hot weather will not do that as much. Um, and birds, like humans like to do, if it's very hot out, you find some water. You go to a pool, you take a dip. And for birds, this can be natural bodies of water, or, if you have a bird bath, that can also be a great way for a bird to keep cool. Birds can also pant. So this is slightly different than the way that a human or a dog might pant. But to get rid of some heat, some birds will move the skin on their throat and breathe rapidly. So what this does is it kind of forces air in and out of their mouths very quickly. And because all the moisture in their throats, that'll evaporate and it will cool them down from the inside. So these are some cormorants. This is also down in Alston. And you can see this, I think, was a hot day. I'm going to run this video. You can see several of these cormorants. You can see them moving their throats. That's their gular. That's called gular fluttering. Like I said, they're basically forcing air in and out of their mouths very quickly. And since this encourages evaporation, just like evaporation on a human helps cool you down, evaporation in the bird's throat helps cool them down. So I think that's really neat to see. To other tips and trips for getting rid of heat. For some birds, like toucans and hornbills, their beak actually helps them get rid of heat. They have this big honking beak, and it provides a way for the blood to cool in their body. Now, this second one is maybe a little bit grosser, but for some birds, like turkey vultures and wood storks, they sometimes poop on their feet. This is called orohydrosis. And by pooping on their feet, that poop has moisture in it. As that moisture evaporates, it cools the skin of their feet. So even though it's not the most nice thing to think about, if it helps birds survive, then all the better. And there is some suggestion that maybe some birds fly higher because as you go up in the atmosphere, things get cooler. So if you're a bird and you can fly, maybe you might just go up in the atmosphere, fly around it at high altitude for a little while to cool down. But the other part of living in a hot area is you need water. So how do you stay hydrated in dry places? Well, for us people, we sweat. And when people sweat, we're getting rid of water to get rid of heat. So we put liquid water on our skin, that water evaporates. That process of the sweat evaporating requires heat. So it takes heat away from your skin when that sweat evaporates. However, birds don't sweat, other than kind of in their throat with that gular fluttering, so they don't lose water this way. Oh, sorry, wrong emphasis here. Birds don't sweat, so this is a way that they retain more water. So if you're a bird, you have your water, you're not going to lose too much of it due to sweating, which is good for water conservation. Birds can get a lot of water from fruit and insects. Fruit and insects contain a lot of water. Many birds can get most or perhaps all of the water that they need purely through eating insects and fruits. Also, if you're a bird, you don't want to waste the water that you have. And I think this is a kind of interesting topic. Again, it's a little bit gross, but bird droppings don't contain much water. So when they excrete their waste, birds don't lose much water this way. This also ties into flight. For a bird, you want to be as light as you can be because you need to be able to carry yourself with your wings. So water is heavy, so you don't want to have a ton of water, um, inside. You don't want to have to use it for waste. Uh, Also, a lot of birds don't have a ton of fat because fat would weigh them down. So this presents kind of a survival challenge where a human being, if you don't eat and drink water for a day or two, you'll survive because you have fat resources. But for a bird, they don't want as much fat because they need to be able to fly. So they have to continually be able to find food and water. So another source of water for birds is some birds can drink salt water. Like here's an example of a seagull. They can drink salt water directly, and they remove the salt using a salt gland. Here you can see kind of a demonstration. They have this salt gland above their eye, and what ends up happening is they have this little hole in their beak, and after drinking the salt water, a concentrated saline solution will drip out of this hole and then drip onto the ground. So this is how they drink salt water, and then this gland helps them get rid of the salt so that they just have the water left. Because like for us, if we tried to just drink salt water over a number of days, that would not hydrate us. But some seabirds don't have this problem. Okay, so we've talked about cold weather and we've talked about hot weather. Let's talk about storms. Research suggests that birds can sense pressure. So often storms are associated with decreasing pressure. The pressure starts to drop. If you have a barometer on the wall and you see that mercury dip or that dial turn, like this one, to lower pressures, that's an indication that a storm might be on the way. And it seems like birds can sense the pressure. And this is comparable to maybe one of your relatives say, they can feel it in their bones or they can feel it in their joints when the pressure is going down. So birds seem to be able to sense pressure, and when the pressure is dropping, that might mean that bad weather is on the way, and they can take actions to prepare for it. It's possible that birds can also hear storm sounds at frequencies that we can't. So maybe they'd be able to have other senses that can tell them, hey, a storm's on the way. You need to prepare for this. And here are two papers that kind of talk about this. You can see that on the right, this one's talking about white-throated sparrows adjusting behavior in response to manipulations of barometric pressure and temperature. Basically, that when the pressure and the temperature is changing, these sparrows seem to change what they're doing. They adjust their behavior because if they know a storm's on the way, then that requires other activity. And okay, so if you have a sense of the pressure and you have a good sense that a storm's on the way, what do you do? Or in other words, that common question, where do birds go when it rains? So the first step for a lot of birds is getting something to eat. So if a storm is on the way, a bird wants to fill its belly. So you might see a lot of birds at your bird feeder or birds getting food other places. By stocking up on calories, then when the storm hits, they can just hide somewhere for an extended period of time. And with a full belly, they don't have to go anywhere and they can just ride out the storm. So that's the second step. After they've filled their belly, find somewhere sheltered and hunker down. So this could be thick shrubs. It could be beside a tree downwind, so they're kind of buffered from that wind, or a hole in a tree. Or for some birds, if you don't have that kind of shelter, maybe you just have to face into the wind to be a little bit more aerodynamic, and then you just hunker down and wait for the storm to pass. And because you've filled your belly, you don't have to go anywhere. It does seem that some birds, instead of hunkering down under a storm, they might avoid storms entirely. Because, if the pressure's dropping, a storm's coming, good strategy might be to leave the area. So you can see here's a paper, Tornadic Storm Avoidance Behavior in Breeding Songbirds. I believe this example, or a different example, was golden wing warblers, where they may leave the area or alter their migrations in advance of a storm. So they might go somewhere else for a few days. Or if a storm's on the way and they're planning to migrate back, they might delay their plans for a few days just to wait out the weather. This is a little stranger. There seems to be some evidence that some birds may actually head into a hurricane. So instead of trying to be in the windy part of the hurricane, these seabirds may fly directly into the eye of the storm. And the eye of the storm is nice and calm, and if they can stay there, they reduce the risk of being flung into the ground due to the winds. And an example of this might be shearwaters. And if you look around, say on YouTube, you can find some radar imagery of what appears to be a flock of birds in the eye of a storm. I don't know if they got there intentionally or just by accident, but they stay in the eye of the storm, stay aloft, and that helps them from crashing into the ground and staying safe during the storm. But scientists are still learning more about this. The world of birds is wonderfully large, and we're learning more all the time how birds live and adapt to the weather. So I've shown some research here. More is being done all the time. So, over the next few years, we might learn even more. Let's talk a little bit about birds and the wind. As flyers, most birds spend a lot of time in the air. They do deal with the wind. They need to know how to navigate the wind. So the first step in this would be, if you're a bird, how do you catch the wind? The first step in that is taking off. Birds will often sit facing into the wind. This helps them be a little bit more aerodynamic. It keeps the wind from ruffling their feathers too much. And then for taking off, they may take off into the wind. So human pilots prefer this too. They prefer having their planes take off into the wind. It ensures that the air will move over the wings properly and provide lift. Birds seem to like this too. So often they will take off into the wind. For some birds, they need to run or jump from a high place just to get that initial momentum to fly. That's the case for some heavier birds. Now, once you're in the air, some birds, like turkey vultures, will ride thermals to glide higher. Some pilots will actually look for this too. If a pilot is in a glider or a little plane, they may look for birds circling to figure out where the updrafts are, because the pilots may also want to use that updraft, and the birds are a good indicator. To help with flying, some birds also fly in formation, like Canada geese. This helps them save energy because the wing beat of their neighbors helps lift the air where they are, and they're all helping each other. This means that the birds in front help the birds behind. And I believe they shift order from time to time so that the same birds aren't always in the front. So here's a question I want you to think about. I guess you can't respond verbally right now, but just think about it right now. If you had to nominate a bird, what bird do you think is the best flyer? And I'll give you a few seconds here just to think about this, and then I'll mention some nominees. Okay, I should tell you there's no right answer here. But I think since birds spend so much time in the air, wanted to point out some notable flyers. Probably a lot of these you've heard, some you might not have. So hummingbirds, maybe that's a nominee. Hummingbirds, they can fly very quickly, they can hover, they can even fly backwards. Wandering albatross, glide over the Southern Ocean with 11-foot wings, which is just spectacular to me. That's a massive bird. Common swifts seem to be able to fly for months without ever landing, which is incredible. Great frigate birds seem to be able to sleep in flight. Other birds seem to be able to sleep in flight as well. And I think there's some suggestion about how they do this, whether this is kind of, they're not doing like a person and sleeping for hours at a time, but they may be able to have kind of micro sleeps or perhaps allow part of their brain to rest at one time and part of it be kind of aware. Bar-headed geese can fly over the Himalayan mountains. Arctic terns have an incredible migration. They spend part of the year in the Arctic, and then they migrate to the Antarctic on the other side of the planet, and then they migrate back, and they do that every year. And that's just astounding to me. And peregrine falcons can dive at 200 miles per hour. So because birds spend so much of the time in the air, and the air is such intrinsically linked to weather, I just wanted to talk a little bit about fun flyers. So as a last topic, I want to talk about birds and climate change. So birds over the millennia have adapted to many challenges. They seem to be descended from some sort of theropod dinosaur and have been around for millions of years. Climate change is going to make things more difficult. So climate change will affect birds in many different ways. Temperature will affect bird ranges. And you say, okay, well, even if it is getting hotter, maybe birds will just move to cooler climates to keep their preferred temperature. Well, that raises a couple challenges. Um, will there be enough of the food that they eat in those new locations? Because food, plants, etc., do not shift their ranges immediately. So even if a bird goes to a new range, a new location, there might not be any food for it to eat. Also, there might be other competition from birds or new predators in that location. So even though in theory they could move somewhere else, this presents a lot of trouble. Climate change also presents a challenge for migrating birds. So migrating birds, they'll fly somewhere in the fall and then they'll return in the spring, and they have migratory patterns that when they come back to a location, say in the spring, they return to their normal grounds, they line that up with the development of food, the flowering of plants and fruits, so they have things to eat. But if climate is going to change, it might be that they've made this long migration back to their typical summer grounds, and maybe the plants have not flowered yet, and maybe there is not the food that they expect to be there. And you can imagine that at the end of a very long flight, if you don't have any food waiting for you, that can cause problems. And also more traditional things with climate change. Perhaps more drought, perhaps more fire, perhaps more intense storms can all kill birds directly. So here are a couple tools. You guys might be familiar with these. But the Audubon.org has tools for lots of different bird species. You just Google whatever bird species you're interested in, you come to its page, and on the conservation tab, you can find predictions about how climate change will impact the birds' ranges. And you can change the warming scenario from something more mild to something more dramatic and see if it has lost range or gained any ranges as it perhaps moves to new locations. And this is an example of a northern pygmy owl. Audubon has a different tool. It's this audubon.org/climate/survival by degrees, where you can look up any given region and it'll tell you what birds are vulnerable, or moderately vulnerable or more stable in whatever location. So I pulled up Texas, since that's where most of you all are right now. And you can see that there's a number of birds under this highly vulnerable category. So these are just tools that you can check out later if you want. I think they're very useful to see the potential impacts of future changes. And, if you want to try to help, what can you do? So for birds in general, support wildlife preserves, support native ecosystems and vegetation. This means, if you're planning to plant new vegetation in your yard, maybe consider sticking with native vegetation instead of something more exotic that might look nicer. Because birds rely on these native plants for food. It's what they expect to find, it's what they're equipped to eat. Starting conversations with people can help, and also voting to combat climate change. So that's most of what I had for you about birds and the weather. I hope this was a fun, kind of broad overview of the topic. The different adaptations that birds have to deal with the cold, like torpor, those mini hibernations that hummingbirds do, or dealing with the heat, different social things like huddling together or um, not fighting during the hottest times of the year, or even how they deal with water limitations by having less water in their excretions so they don't lose as much that way, or by not sweating. So, and just to wrap up, I thought I'd mention I do have a few books about birds and the weather. These are my coloring books. One is about the Southwest, where I live right now. One is kind of a general introduction to birds. In addition to pictures, these have a lot of information, especially this introduction one has a lot of fun information about birds. And then there's a little tiny book about hummingbirds. I've also written some weather mysteries if you're more in the mood for some sort of weather-themed narrative. And these more are written for kids, maybe middle schoolers. But these are two books starring Kelvin MacLeod, who's a detective who investigates
Oh, good.
weather-themed mysteries. And all of these are on Amazon. Also, check out my website. It's colorbird.org. There's a bunch of free stuff here. You can download a lot of coloring book pages just for free. You can print off on your home computer, your printer. I also have crosswords. This one's about bird names, as well as some other activities like sheets for bird observations. So yeah, that's all free at my website, colorbird.org. So feel free to check that out. And for this talk, I used a bunch of resources. A lot of these are Audubon or All About Birds, as well as some books and US departments. So yeah, and I'd like to thank you all very much. I hope you've enjoyed this. I hope you've learned something. Remember to visit my website if you'd like. And yeah, I think we have a little